Okay, this is the hydrologic cycle handout. I believe it's called Hydrologic Cycle Fill-In. And we're going to walk through this and fill in the blanks. I'm going to type them in. You can fill them in with pen, or you can get the Word document out and type it if you want to. But this shows the different processes that the water goes through. So we're talking about the fate of the water in the environment. So a couple things are shown. For example, there's rain and snow. And then you have snow on the mountain, snow and glaciers. So the rain comes down. That's how it gets from the sky to the earth, that along with snow. So I guess this one should also be rain. And it gets back up to the sky through the process of evaporation. So from the ocean, it goes through evaporation, goes up into the sky. And to make clouds, we have condensation of the water vapor into tiny droplets. Condensation. So we'll put that on this cloud also. We'll put condensation. That's the water vapor becoming a cloud. Now, when we have evaporation from the ocean, from vegetated land, the trees and grass and stuff here, we can have evaporation. And we also, I'm going to cross out the and back up here in a second, but we can have evaporation, and then also the plants sending their moisture up into the air is transpiration. Oops, my transpiration just disappeared. So why don't I make a new word called evapo that combines those two. Evapotranspiration. So that's the combined effects of evaporation and transpiration. We can't really separate it. We just know that we have moisture coming up into the air from this vegetated land. Some of that's due to evaporation, some of that's due to transpiration by the plants. So we put that together and we call it evapotranspiration. It can also get directly from the snow up into the air through a process called sublimation. I don't know that I've ever said the word sublimation except in class. The students seem to know that for some reason. I didn't remember it from when I was a student, but maybe if you live in the mountains you know all about sublimation, but I don't. And this would also be condensation up in this cloud here. Now when it's up in the air, it can move around, and we call movement with the medium in this case being air, the air moving and the water moving along with that, we call that advection. Or convection, we can use the same thing, but I'll call it advection. That's just movement in the air. Okay, so that's how it gets from the surface to the air, and then we hit, it can come from the air to the surface in snow or rain, and then the snow on the mountains can also come into the streams with snow melt, or I'll say melt runoff. And that is a significant source of water in rivers. For example, the Arkansas River runs through Arkansas. It starts like thousands of miles away in the mountains of Colorado. I was driving through Colorado years ago one time, and I see a sign that said the Arkansas River, and I was like, oh, interesting, they have an Arkansas River here too. And actually it's the same Arkansas River. It runs down. So then the river is also fed by runoff and fed by groundwater, but it can start in the mountains as snowmelt. So the rain comes down and hits the surface. What we're concerned about is, well, we need to know how much rain is coming down. That's a central part of what we do when we're assessing the runoff and low impact development, but we're concerned about the runoff. So I'm going to put runoff here, and then in this box here, so it's moving across the land as runoff, I'm going to put overland flow. Overland flow is probably a little more rigorous term for the water moving over the surface than runoff, but runoff is from the rain. We also call it, we'll call it when we do the hydrology. Remember, this first unit here, the first unit is background and some general things about low impact development. The second unit is going to be on the hydrology, and we'll call it excess precipitation at one point. So it's the precipitation that runs off. But it runs off there. We have overland flow. We have overland flow and melt runoff into the stream. We also have the groundwater into the stream. We can end up with stream flow. I can write stream flow. I'll write it as one word. So our interest is the runoff, its effects on the land, the overland flow, and then also its effects on the stream flow. We're trying to limit the impact of our runoff, our increase of runoff of the natural environment, so we want to try to limit its effects on the stream flow. So it's running across the ground. It can get into the groundwater through infiltration. So that's what I intended for that box there, is infiltration, and then it gets from the surface into soil moisture and groundwater. Groundwater can be one word or two words. Either one will work. So I'm making a distinction there. I'm calling it, and I got this particular graph, the original version of it, and I put in the boxes there from this website, physicalgeography.net. They use the word term soil moisture as one of the terms for the moisture in the soil above the water table. That's the vadose zone, or the unsaturated zone in the groundwater, and there's quite a bit of moisture there. And for the low impact design technologies, we're interested in that as a storage place for the moisture. It moves through there into the groundwater. We do want to recharge the groundwater through infiltration. And it can also come back out of there through vegetation, can take it out of the soil moisture and put it into the air through evapotranspiration. But the distinction there is the distinction between the soil moisture and the groundwater in the saturated zone, or we could call this the groundwater in the unsaturated zone, but we're making a distinction here between soil moisture and groundwater. So this arrow here would be groundwater flow. So groundwater also moves by advection through potential flow. It flows downhill from high potential to low potential. In general, it does follow the surface contours, so it goes downhill. Now, high potential to low potential, so for example, the groundwater is from up here, and it's flowing down through this way. It's flowing downhill on the macro scale, but if there was a hill in between here that went up like that, and I stuck some wells down there, the hill is sloping down this way, and the groundwater is actually going the opposite way. So it doesn't follow the surface contours exactly, but in general, it's going to be draining toward the ocean and can be draining toward the stream. I might ought to have another box here, so I have a box with, I'll move my head there a little bit. I have an arrow going from the groundwater into the ocean. I can also have an arrow in the groundwater going into the lake. You can see here it shows this lake intersects the groundwater a little bit. I can have a flow from the groundwater to the lake and from the groundwater to the stream, or vice versa. I can have a gaining stream, which groundwater is going into the stream, or I can have a losing stream. It's going from the stream into the groundwater. Here in where I live in Pennsylvania, I actually live right on the Yellow Breeches Creek. It's a popular trout fishing, and floating creek, kayaking, and inner tubing. My daughters inner tube almost every day in the summer. I pick them up here on campus at Messiah College. I actually kayak to work. Not every day, but I have kayaked to work. I can leave my house, have an inflatable kayak, jump in the creek, and the creek runs right through the middle of campus. But that creek is a pretty steady flow, even in the summer. It's fed mostly from groundwater. It remains cold and clear in the summer. And really the runoff, I'm surprised. I was used to, after living in northwest Arkansas, I was used to the Ozark streams, real steep banks, and the water rose real high when there was a storm. Yellow Breeches doesn't rise that much. I mean, it does rise, but it has a real flat floodplain between the hills, so it dissipates a lot of energy with just a little bit of rise. So it doesn't get that high. It does get high enough to flood my basement every time there's a big storm. But I kind of wish my landlord had told us that before we moved in. But anyway, that's the stream maintaining a steady flow even in the summer shows that we have groundwater running from the groundwater to the stream. And likewise, that can happen in a lake. So actually, this box here is soil moisture. This box here is also supposed to be soil moisture. And this box is groundwater. Again, either one word or two words. So the last box I have here, I'm showing it moving from the soil moisture into the groundwater. That I'm going to call percolation. Percolation and infiltration are pretty much synonymous. If you do a test to see how fast the water can perk from your septic tank system, drainage system into the groundwater, you do a perk test. You dig a hole. So that's infiltrating from the hole down into the ground. That's percolation. So we're making a somewhat distinction between infiltration and percolation, but really percolation is part of infiltration, or infiltration is the first step to percolation. Something like that. Anyway, they're related. So this is overall the processes for low-impact development technologies. We are working with traditional stormwater management. We are collecting the water to not impact the stream flow and control the runoff a little bit maybe. Low impact development, as we've done at least twice so far, we said we're using the three processes. We're using evapotranspiration, any technology where we plant something, a rain garden, bioswale, bioretention. Part of that bio is to get the plants themselves to take up some of the water, and that will leave the system into the air. Our other thing we're trying to do is infiltration. We're trying to get it to go into the ground, into the soil moisture, at least temporarily. Now, some of our technologies, we use drains under that to, after we take it through the soil moisture, then we can drain it out sometimes, and what we've done is we've filtered it, we've improved the water quality, and we're also allowing maybe some evapotranspiration. But most of those technologies, the end goal is try to get it to recharge the groundwater. The third we've mentioned is the reuse. That doesn't show up on our hydrologic cycle map here.